Now, you might have skipped the BCA video, and that's totally fine. A lot of people like to stick to stoichiometry. This is the way that I will show you that I work through most problems, because most of the time I don't actually care how much excess is left. Sometimes it's important, but most of the time I just want to know how much stuff do I need and how much stuff I'm going to make. So I'm going to do regular stoichiometry. Now, the word stoichiometry, if you break it down, stoichio means the elements, and ometry is, of course, the study of. So it is the study of the elements, but specifically the quantitative study of chemical reactions. So how much stuff can I make, will I use, and so on and so forth. So when do I do stoichiometry? This is also applicable to BCA tables. When do I need to do these problems? If there is a chemical reaction, so if I give you a chemical reaction and I asked for amounts of stuff, so grams of stuff or moles of stuff or molecules of stuff, and it's not just a conversion and there's a reaction that happens, you have to do stoichiometry, which really means we need to use mole ratios at some point. So this is how we do it stoichiometry wise. It's 3 steps. It's always 3 steps, and it's always the same 3 steps. Okay. Usually I give you grams. So what we need to do first is convert to moles. Now, if you're already in moles, you can skip that step. Okay. You just got to be in moles, because if you remember a balanced chemical equation, those coefficients are mole numbers, not mass numbers. So you need to convert to moles. Second thing you need to do is do your mole ratio, which you find from the coefficients in the balanced equation. So you did have to have a balanced equation. If you don't write a balanced equation, you can't do stoichiometry. Okay, so convert to moles, do the mole ratio. And then if I ask for grams, you need to convert back to grams. And to get from moles to grams, you multiply by grams. So really, in most problems, you're going to do convert grams to moles using molar mass. Use the mole ratio, so something over something, and then convert to grams. So then you will multiply it by a different molar mass, because I'm asking for something that's different. Okay. And then when you do this calculation, your theoretical yield, so if I ask like, how much should I make theoretically? It's whatever your answer is. So whatever I got here as my grams of my product is my theoretical yield, the amount of product made via calculation. Because let's be honest, we don't always make 100% of our yield in lab. We like never make 100%. So convert to moles, mole ratio, convert to grams. That's what you should be saying over and over in your head. Now, sometimes you don't have to do step 1 or 3 if I'm already in moles or if I asked for moles, but you always have to have a mole ratio if there was a chemical reaction. This is the most important step. Okay, so I am going to show you how to do one of these in a minute, but before I do that, I want to talk about percent yield. Okay, so if I want to know what your percent yield was, so theoretically, I should make whatever I calculated, but in the lab, do we actually usually make 100%? No. So to calculate that percent yield, the percent yield is just the actual amount, so like how much you made in lab. This isn't something you can calculate. If this isn't a problem, it's a number I have to give you, over the theoretical yield. How much should I have made based on my stoichiometry math times 100? Now, a lot of the times we end up, like I said, with less than 100% because maybe some of it fell off the scale, or some of it was stuck to the sides, or some of it didn't react all the way, something like that. So a lot of the times we'll get less than 100% yield. Now, if you get more than 100% yield, then maybe it's wet, you didn't dry it all the way or something like that. It can happen, but we hardly ever get spot on. Okay, so percent yield is also going to be something I will have you calculate. So 3 steps for stoichiometry, and then this is how you do the percent yield of whatever you did during lab. On to some examples. So example number 10. What mass of PCl3 can be obtained or made from the complete reaction? Okay, notice it says reaction, that means stoichiometry, of 0.45 grams of P4. Okay, the balanced reaction is this. Now, if I give you a balanced reaction, you don't have to check that these are the correct coefficients. I'm never going to give you a wrong balanced equation. So this means that 1 mole of this will react with 6 moles of this and produce 4 moles of this. Okay, so like any problem, I'm going to start with the number I gave you in the problem. I'm going to start with 0.450 grams of P4. Write your units so you know what cancels out and what doesn't. So I have this, but I want mass of PCl3. This is a completely different compound. Okay, so it's not just 0.45 grams, it's going to be a different mass. This is a 1:4 ratio. So this is what you do. Okay, start with your number, convert to moles. So, well, I have this many grams of P4. What is the molar mass of P4? Well, it's 124 grams of P4 is 1 mole. That will cancel out my grams. That'll get me to moles. So this was step number 1, convert to moles. Now don't do your math until the end, set it up first. Step number 2 is use a mole ratio. So this was this was mole ratio. Now mole ratios are, remember, numbers from the balanced equation. So a 1, a 6, a 4, and you just use the ones that you need, okay? I had moles of P4 over here. So P4's coefficient, which is just 1, is gonna go on the bottom. So those cancel. I want PCl3, so its number, its coefficient is going to go on top. So this is my mole ratio, is 4 moles of PCl3 over 1 mole of P4. So then my moles of P4 cancel out. Now I'm in moles of PCl3. If you're not sure which one to put on top and one to put on bottom, again, watch your units. But it's also always going to be wanted over given. So what I want, PCl3, over what I was given, P4. They're always going to be whole numbers, and they're always going to be from the balanced equation. Okay, so this one's a 4 to 1. Now, I do want to know mass, so I need grams. So I need to do step 3, which is where I convert to grams of PCl3. So this time, 1 mole of PCl3 is, the number goes on top, 137.5 grams of PCl3. So then when I type this into my calculator, I do 0.450 divided by 124. Times 4 times 137.5, and I get 2.00 grams of PCl3. That is how much I should make. That is my theoretical yield, is another word for it. That is how you're going to do your stoichiometry. It's always going to be convert to moles, mole ratio, which is wanted over given from the balanced equation, and convert to grams. Okay, so now I'm going to have you calculate a couple of things. If you want to try example number 11 by yourself and then have me explain it, go ahead. But I'm going to start here. I've got this equation, okay, 1 to 4 to 3 to 4 ratio. Great. I have 6.82 grams of Fe3O4 and 4.95 grams of CO. I gave you 2 starting amounts. So what do you do? In the previous example, I only gave you 1 starting amount. I didn't tell you how much Cl2 I had. That means I had enough Cl2 to do what I wanted. But now I have 2 amounts. I have an amount of this and an amount of this. So what you need to do is do 2 stoichiometry problems. So 2, convert to moles, mole ratio, convert to grams, and figure out which one is your limiting reactant. So which one is going to limit the amount of product you can make. So I would do 1 stoichiometry problem where I start with 6.82 grams of this Fe3O4. So that's this one. And another stoichiometry problem where I start with 4.95 grams of CO. Now, if you just pick one and go with it, you're going to lose points and you're probably going to get the wrong answer usually, because you have to check both to see whichever one is your actual limiting reactant. Okay, I gave you random amounts. You're probably going to run out of one. I did not give you the exact amounts you need of both. So I'm going to convert to moles. So this one is Fe3O4. So this is the molar mass to 1 mole. I'm going to do the same thing for CO. This is 28 grams to 1 mole. So that's my convert to moles. Then my mole ratio. Okay, what am I trying to get over what I was given? Now, I want to know mass of Fe. So that means Fe, which coefficient is 3, goes on top for my mole ratio. And it's going to be the same for both of them because either way, I am trying to find iron or Fe. So it's 3 moles of Fe. This one is also 3 moles of Fe. The wanted is the same. However, in this one, I was given Fe3O4. So that has a coefficient of 1. So 1 goes down here. And in this one, I start with CO and its coefficient is 4. So this is a 3 to 4 ratio. Okay, so I got my mole ratios, wanted over given, and then I convert back to grams of whatever it is I'm looking for, which in this case is iron. So the molar mass of iron, and then I can do my math. 6.82 divided by 231.55 times 3 times 55.8 gives me 4.93. And this one gives me 7.40. So you might be like, okay, well then like, what's the answer? I did 2 of these. Well, what I just did is calculate the amount of stuff or iron I can make based on just this number and the amount of stuff I can make just based on this number. So whichever one is less is how much you can make. It limited how much iron you can make. So this is the answer. This is not the answer. You might be like, well, I didn't even need to do the second one. Well, you wouldn't have known that unless you'd actually done it. So you have to do it and be like, okay, this is my theoretical yield. This is how much I could potentially make. 4.93 grams, because I'm going to run out of this Fe3O4. I have 6.82 grams. I need more. If I want to make more, I can only make 4.93. So this number is my theoretical yield. This guy is my limiting reactant, and that means I'm going to have some leftover CO. So if I give you two numbers, you have to do two stoichiometry problems. Okay, so then I said if the reaction generates only 4.50 grams of iron, that would mean like if I did it in lab, this reaction generates or made this, what's my percent yield? Okay, the lab amount is not an amount you calculate. So you do your lab amount over how much you should have made times 100. So I would do 4.505 over how much I should have made based on calculation is 4.93 times 100. I got an 82.8% yield, which isn't terrible. That's pretty good, especially for an